Welcome to ARM Presents Fireside Chats, panel discussions looking at the business potential of technology. In today's podcast, we're focusing on the $6 trillion importance of security. While digital transformation is opening the doors to new business models around the world, it's also leading to new threats. By 2021, there will be trillions of dollars of cybercrime losses along with damage to company reputations. In this fireside chat, join PSA certified and cyber insurance experts Munich Re to discuss risk modeling, liability, and security solutions to future-proof your products and platforms. Today's moderator is Anurag Gupta from PSA Certified.
Hello everyone, I'm Anurag Gupta, Director of Business Development for IoT Security within Architecture and Technology Group at ARM, working with original equipment manufacturers and their ecosystem to raise the bar of security within their products based on secure design principles. In this fire chat, we will discuss the relationship between device security, deploying at scale, and delivering assurance. We will also discuss in what ways the new hyper-connected value chains impact the risk portfolio and risk capital, along with how the responsibility and liability for failure be defined and managed in these complex value chains. For this, today we have three amazing panelists with us. Peter Armstrong, the Senior Cyber Subject Matter Expert with Munich Re. David Maidment, who is the Director of Secure Devices Ecosystem within Architecture and Technology Group at ARM. Duncan Jones is Senior Product Manager, Pelion IoT Platform with ARM. I would start by saying that as leaders in the technology field that stimulate the connected or IoT revolution, we have to consider how we are going to help to equip the client world to understand the complexity of managing devices at scale with surety, security, confidence, and assurance. So with this, Peter, from an insurer point of view, could you walk us through how you see the current dramatic changes or hyper-connected devices are impacting the insurance risk world along with critical challenges? Secondly, what innovation opportunities do these challenges bring to the insurer?
Sure, Anurag, and thank you for the introduction. Digital transformation, as we might call it, has spawned loads of new devices, new levels of connectivity, new companies even, and certainly many new value propositions. These new and in some cases hyper-connected value chains are already hugely significant and in turn are changing significantly the risk profile of our clients' risk portfolio. So what do I mean by that? Well, let's take big oil. Digitization of remote operations management and remote condition monitoring of processes and the equipment that enables that has transformed long-established cost and investment models in exploratory drilling, for example. So if we think about the relative levels of cost of these activities, historically they have run into hundreds of millions with time spans approaching 2 years. The levels of efficiency and recovery of cost and time as a consequence of digitization are tremendous, meaning that the real benefits of digitization have associated levels of risk that are much greater than in historical processes. This means that the portfolio of risk has changed dramatically, and an insurer needs to be able to quantify the risk and understand the quality of that risk in order to be able to underwrite it. Understanding the roles and responsibility of multi-party disaggregated information supply chains. That's a mouthful, but what it means is many organizations involved in the processes providing services, microservices, information devices in that value chain impact upon the delivery of the value to the client. And understanding that is our task. For clients themselves, risk managers need to understand the expectations that they have of partners, both up and down the value chains, that are already here, And insurers will need to be able to break down liability in these value chains in order to ensure both visibility of the quality of the risk and also to be able to disaggregate the liability responsibility to reflect the complex mix of service providers, original equipment manufacturers, OEMs, and so on, that are involved in delivering the services in the value chain. And that's not a trivial task, and it means we'll need the risk equivalent of trusted components in a value process. Why? Well, imagine a process stack adjacent to an open systems interconnection, an OSI stack, where processes are getting richer as the levels of aggregated information increase vertically in the process stack. These risk equivalent trusted components will need to be built upon roots of trust at all levels in this process stack. And these components will need to embrace trusted devices, the protocols associated with or roots of trust that enable the trusted deployment of these new technologies. Now, this innovation and challenge also creates opportunity for innovations. And to your second point, Anurag, we have the opportunity of being able to generate warranties for product, process, equipment performance, and so on. We can ensure product recall. And of course, the task of cyber risk quantification and roots of trust compliance and certification. I think bringing these themes together, for sure, viewing risk and liability from a client's perspective as they seek to establish hyper-connected value chains will need to become a standard approach to reviewing the viability and relevance of technology deployment.
Thanks, Peter. Interesting view on the qualification and quantification of the risk. David, if we think about IoT devices, how would you say that they are evolving and what are the major trends you see today? Also, whether an OEM or product manufacturer need to think differently now while building a product.
Yeah, thanks, Anurag, and thanks also for the intro. I think it's fascinating actually listening to what Peter's talking about, and what we, I guess as an industry, what we rarely do is think about the sort of the spanning all the way from the product. You know, we talk about an OEM. So an OEM is, original equipment manufacturer. So they're the guys that make, physical products that you actually put into service. Now, in the electronics industry, we think about product a lot, but actually with the Internet of Things and with digital transformation, the product actually drives the acquisition of data, which is then used to deliver new services or new efficiencies into multiple industries. So that link between product and service is something that, from a digital transformation and IoT point of view, I think as an industry, we need to think about a lot more, particularly as the electronics industry, where we're building the physical devices that are being deployed in the field. Digital transformation, as Peter was talking about, it spans across all markets, actually. So, you can think about industrial, transport, logistics, building. It's all about scale. It's all about deploying, an order of magnitude large number of devices that can then create these new services and efficiencies as companies and entire industries go through digital transformation. So that's a massive deployment of devices, and I think Duncan's going to expand on that a little bit later on in the podcast. I think it's a massive deployment of devices. It actually goes beyond the traditional IT model where you're, with traditional IT, you're deploying in a somewhat managed environment. You have a relationship with the device. I think with IoT, you have a massive scale of deployment. You have a huge number of devices that require, installation, probably with zero touch. They need to be able to connect, and that connection goes beyond what you see in traditional broadband and cellular networks today. Which is where we see technologies such as 5G coming in to allow a massive number of devices to connect. Once you've connected all those devices, you need to make sense of all that data and turn it into a valuable service, and that's where we see technologies such as artificial intelligence coming. So, you kind of see this themes really being driven from what the electronics industry is delivering. where, an individual product has to be trusted. And Peter spoke, very well around, the fact that it needs a root of trust, and we'll talk a little bit more about that in due course. But effectively, you're establishing a chain of trust all the way from the device, its acquisition of the data, and all the way through to the service. So, effectively, if you trust the device, you trust the data, and you're establishing that chain of trust. And I think that's essential, particularly back to the insurance world, where at the end you have business critical services that are being delivered. So establishing that chain of trust is what it's all about.
Duncan, David was talking about scale and assurance. So now thinking from the deployment perspective, how does this opportunity get realized?
Thanks, Anurag. So, Peter and David both spoke about roots of trust, and I'd just like to second that as an important topic, because obviously if we can't trust the data that we're getting from devices, we will never realize the full value of IoT. However, in my experience, customers that we speak to, they want to focus on building their business applications. So Peter already gave the analogy of the OSI stack. I think that's a good analogy. Our customers, for example, they want to be very high up the stack. They understand their end domain, whether it's wind turbines or waste disposal, but they don't necessarily understand public key infrastructure particularly well, or down at the chip level, knowing what trust zone is or how to protect roots of trust. And unfortunately, as we scale the number of IoT solutions and the number of devices in those solutions, we can't necessarily scale the expertise needed to secure those solutions. And so because of this, I think device management platforms are now recognized as a necessary part of any sizable IoT solution. And this is ultimately how we can realize this opportunity. It's to let the different parties do what they do best. So our customers understand their business and they know what they need to achieve, and we need to enable them to do that. And device management vendors such as Arm can focus on keeping the solution secure. I think that's the way that we actually make this happen.
So now we understand the opportunities and challenges ahead of us through digital transformation, both from insurer and device manufacturer point of view, and more importantly, when we deploy at scale. So let's discuss and look into some of the specifics around delivering assurance. So Peter, could you perhaps explain the role you see for insurers to help address some of the challenges you spoke about, specifically the intersection of technology and business assurance? What should be they doing more, in your view, both from direct insurance as well as reinsurance?
Sure. Some important points from David and Duncan earlier, but before really answering this question, we need to have a semblance of understanding of the insurance market. An insurance market, for example, like the one for cyber insurance, depends upon the availability of capital. And capital availability depends upon trust and believability of risk. There are two types of insurance. There's direct insurance and reinsurance. Direct insurance is typified by Chubb writing and underwriting a risk either with a client or with you as an individual for your motor car. And reinsurance is the means by which Chubb spreads their risk across a broader insurance market. So they will sell buckets of like risk, so loads of cyber risk for retailers or loads of car insurance for homeowners and so on, to a reinsurer who will then retain some of that risk and then in turn spread that risk to alternative sources of capital. What we mean by that is just other sources of capital other than insurance capital. Now, direct insurance and the ability to write premiums is wholly dependent upon their ability to spread their risk to reinsurers. And reinsurers require a level of confidence in understanding the worst case scenario. And that's not straightforward for something like cyber insurance. And in order to attract other sources of capital, they have to be able not only to persuade themselves, but others. And knowing what the worst case scenario is for a cyber risk is really hard because of the almost infinite variability at the front end of the risk. If we can't quantify cyber risk in a meaningful way, then there isn't going to be enough capital available. And I'll draw a comparison here. Political violence and terrorism, 10 years ago, you couldn't get capital to provide insurance until someone came up with the idea that the worst case scenario was probably a dirty bomb on London and a dirty bomb on Wall Street at the same time. Now, whilst the damage that causes is a big number, you can quantify it, and as a consequence, billions of dollars of capital became available. It's really hard to do that for cyber risk. And in the context of these new value chains, the hyperconnectivity makes it all harder to quantify because the massive disaggregation of technology down to embedded devices that are enabling these value chains means it's really difficult to get sight of all of the different aggregation factors. That means capital is somewhat constrained, and only those organizations who can point to surety and confidence in the embedded processes and devices, going back to that OSI comparison process stack, will be able to attract capital at a meaningfully and affordable quantity and price. This means that we do need to be able to model and quantify the risk, and it means that we need to try to minimize the front-end risk variables that I have to deal with in order to quantify and qualify a risk. And that means, as I said earlier, we need the risk equivalent of trusted components to be built upon the roots of trust to make this sufficiently transparent to be a viable outcome. Without it, we won't be able to identify the breakdown of liability in these value chains, and we won't be able to offer the insurance capital that is necessary. The implications of that for the technology industry is that it will slow down deployment and adoption, and there'll be a level of uncertainty around the new value propositions that IoT seeks to enable.
Duncan, we heard David saying that in order to make some business decisions, we need to trust the data, and that data need to come from trusted devices. So with that, we see that scaling is central to enable the digital transformation agenda. Can you share some of the challenges you see with that?
Sure. I mean, there's a lot of complexity when you get into a real-world IoT deployment. I mean, it tends to be, to start with, quite a mix of devices that you have to work with. I mean that both in terms of, their size and capability and the type of them, but also, whether they're brand new devices that are being built for this solution or whether they are legacy devices that are being kind of embraced in some kind of, digital transformation process. When you deal with legacy devices, you have to think about how you are going to integrate them, and that often means thinking about how you can translate their existing protocols, at the low level, into something that can work with your solutions and ultimately, connect to the internet securely. And when you try and do this stuff at scale, obviously all these problems are magnified, and yet, our customers at least expect or are looking for a single pane of glass to manage this through. So really, they need an abstraction layer that hides away all the complexities of managing devices. And of course, we keep coming back to this idea of trust in data. And our customers need confidence that their devices are running the software they expect, that they are operating correctly as well. So they can be sure that the data they're getting is something they can base business decisions on. And that brings a lot of security and health monitoring requirements. And that's just some of the stuff that a device management platform must deliver.
Okay. Thanks, Duncan. Let's move the discussion towards another interesting aspect, that is regulation and standards in this space. Also look, does it help or hinder? So, David, are you seeing any specific device level regulation that manufacturers are needing to comply with? Also, could you provide a view on liability from OEMs and service provider perspective?
Yeah, absolutely. And I think Peter's being really polite. Actually, I'm surprised he's not bashing the desk and shouting at Duncan and I on behalf of the electronics industry. I think we as in the electronics industry need to drive best practice, and in part we will do that through self-organization. And we have initiatives such as PSA Certified, which ARM is a co-founder of, and we're working across the electronics industry to drive best practice. But also, as you rightly point out, governments are waking up to this as well, through regulation and standardization. And I think that until that comes together, you're kind of in this chicken and egg scenario where the electronics industry delivers devices that have an unquantifiable risk. We hear these examples of, security cameras getting hacked. They're shipped with default passwords. They don't have a root of trust, so on and so forth. As an industry, we need to do better in solving those problems, because until we do that, you don't enable those services at scale that Peter can come and underwrite. And that's critical in breaking this chicken and egg cycle of, valuing security, and I think understanding the liability in the value chain at each point. And it's a scary word, liability, and none of us like it. I think, responsibility is perhaps a better word. And the ability for the electronics industry in particular, if you look at the chip market, so the chip guys building in, silicon that's capable of having a root of trust, the OEMs building devices to support that and build in best practice. And then we see, regulations kind of coming along, trying to drive at least a minimum level of best practice. So, we see, for example, NIST in the US, 8259, and California state law as well, driving, kind of certain regulations around IoT. In Europe, there's ETSI 303645. These are complicated documents, and the electronics industry has to be able to track those, understand them, and also, ship at scale, but conform locally. These regulations often are targeted to particular territories. So that's another challenge we face, is how do you show compliance, have an audit trail of compliance, drive best practice, in order to satisfy, Peter's risk modeling for the deployment at scale.
So, Peter, as David was talking about various geographical regulations like ETSI, NIST, DCMS, and state California law, along with industry-specific regulations like IEC 62443. So, do you see and agree that governments are making moves to increase regulation, and is that helping or hindering? Any markets in particular you see being regulated?
Yeah, so it's perhaps surprising, but in some ways, the insurance sector is a follower in relation to regulation rather than a leader and driver and shaping the regulatory involvement. I wanted to reflect on David's observation about maybe responsibility being a better word for liability. In the insurance world, that's a nuance that we won't embrace readily. For us, responsibility all too straightforwardly means liability. And the regulatory environment needs to provide the framework and the infrastructure within which we can apply that rather black and white view of responsibility. There are clearly geographical variations in terms of legislation, and that makes it problematic for an insurer. How can you take a coherent view of liability if the regulatory environment in different jurisdictions is different? And the answer is it's hard. You've got to try and be flexible and reflect those geographical differences. So in Europe, we would see GDPR as yesterday today's news, whereas in South Africa, we're seeing the enactment of POPI, which is the protection of personal information, being deployed with a mandated compliance in a year's time. So there's a variability of regulations that impact upon our assessments here. But by and large, insurance reacts quickly to mandate. So if there is something that is mandated, and that's why I support absolutely what David has said, that the initiatives like PSA Certified are key, as is the integration of those initiatives with government imperatives, because that's how we get the opportunity of being able to measure and judge compliance against a mandated view. Sadly, however, the real world is that there's nuance, there's guidance, and that's much more difficult for an insurer to respond to. It's much more difficult to point the finger. And the defined root of trust protocols that talk to nuanced issues can provide confidence for an easy win for insurers. It can speed up adoption and deployment of the new technologies because we can offer warranties to back those technologies. So in essence, it's important for the technology environment to lead and continue to embrace the requirement for compliance in this evolving environment. And sad but true, insurance is a follower, not a leader here. But the leadership of the technology environment for sure is a help, not a hindrance.
Yep. So we are nearly at the end of today's session. So starting with you, Peter, what would you say to the companies looking to deploy digital transformation technology and how to limit their liability exposure?
So I think the overriding issue is that the availability of risk capital is going to be a critical issue in technology-driven cyber risk. And it's going to demand real enterprise risk management competence within client organizations and the supply chain. Without it, companies' valuations will be affected, cost and availability of risk capital will be affected. And this matters because as the hyper-connected value chains evolve, the interdependence of the well-being of the organizations in those value chains is much more interdependent upon the surety and the confidence of the quality of performance of organizations within those value chains. So understanding multiple roots of trust allows insurers to break down liability into bite-sized chunks so that meaningfully we can get to a place where we can understand where segmented liability resides. Root of trust protocols are critical to this in this complex environment.
Fully agree with Peter that availability of risk capital is going to be a critical issue. So David, as the device landscape is moving fast and is very complex, what advice would you offer and how PSA Certified can help the insurers to assess the fitness for purpose consistently at pace and on real time?
Yeah, absolutely. So I'd encourage everybody that's listening to the podcast to have a look at psacertified.org. That'll give you all the information around PSA Certified. So it's an industry security assurance scheme for IoT. Arm is a co-founder along with 4 of the leading security labs. So CAICT, Riskier, UL, and Brightsight. PSA Certified is based on 10 security goals. So it drives best practice across the industry, areas such as having a root of trust, having secure storage, having secure updates. And crucially, to the point that we've been discussing, it maps to the emerging regulatory landscape and it gives an audit trail of compliance based on the certified products. So insurers like Peter can look at psacertified.org and see a registry of certified devices, which is obviously very powerful.
Thanks, David, for helping us to understand that PSA Certified will lead to establish the chain of trust. Duncan, maybe you can give your last advice to the listeners, maybe just in one line.
Absolutely. I would return to my previous comment about doing what you do best. So I would encourage the companies listening to turn to device management vendors like Arm who build on certification schemes like PSA and solve many of these deployment issues for them. And they can focus then on delivering their business value and getting to market faster.
Thanks. With this, I would like to thank everyone for attending and listening to this Fireside Chat.
Thanks for listening to ARM Presents Fireside Chat. ARM's technology is at the heart of computing and connectivity. Their advanced, energy-efficient processor designs have enabled intelligent computing in more than 150 billion chips. You most probably have ARM tech in your smartphone, and increasingly, it's in the world's most powerful supercomputers. If you enjoyed this podcast, we'd love it if you could leave a 5-star rating and tell a friend. For more information on ARM, visit arm.com.